Hello! If you're seeing me upside down, your video screen does not need adjusting. I'm just having a little fun because we're talking about conic sections. Hallelujah! Okay, so today we get to talk about the last of the conic sections, the hyperbolas. You might remember back from algebra when you had a function that looked like this, and it kind of graphed sort of like this, or on the flip side of that it could be like this. It was two branches, sort of. And the hyperbola in a conic section is very similar, and you'll see that in a minute, but that's sort of what we're doing today. But first, I want you to do the warm-up, give it a try. The hyperbolas are slightly different from the ellipse, so I kind of wanted you to make sure you remember how to find the foci of the ellipse first. All right? All right, so there you go. Here, you have to remember that the a is always the bigger number. And remember that we use this equation, c squared equals a squared minus b squared, to get the foci of an ellipse. Kind of notice something here. You notice how this is minus and this is plus standard form for an ellipse. Okay, that's going to be a little different in the hyperbola, but just notice that. And then c squared equals 1, so therefore c is the square root of 1. And since a is underneath the y, that means our focus, our foci, are also going to be on the y-axis, so you write it as 0 plus or minus 1. And then this would then be, this is a, this is b, so it's 49 minus 45 equals 4, c squared equals 4, c equals plus or minus 2, and since the bigger number is under the x, that means our focus is going to be on the x-axis, so it would be plus or minus 2, 0 for your foci. All right, so instead of having you do vocab and filling this all out by yourself, I decided just to kind of draw the pictures of what you're going to see here for hyperbola in a cone. And what happens is, and I don't have, as you know, I don't have two parts of a cone, but let's say this of a conic section. Let's say this was the top part, and then you would have the cone down here on the bottom as well. And if you sliced through it straight down, you would get kind of a parabola here, but then you would also have one on the bottom. So you'd get two parabolas. It's like slicing the conic section like that, and you get two parabolas. So it's going to be slightly different than this kind of hyperbola, but it's still the same idea. So what you're going to have is, you're either going to have two sort of branches facing out on the x-axis, or two branches facing up and down on the y-axis of the hyperbola. And how you can tell is in standard form, if the x comes first in the equation, you see here this is x squared first and this is y squared first. If the x comes first, the hyperbola is going to be branching out on the x-axis. If the y comes first in the equation, the standard form, then the hyperbola is going to be branching out on the y-axis. Okay? Now some other things you need to keep aware of here. The center for this section is always going to be at 0, 0. The vertex is still going to be your plus or minus a. The focus is still plus or minus c. You do have two of them here again. You still have a b here. The b is on the opposite axis, but it really doesn't have much to do with the picture, but we need it for the equation. Okay? And the new thing that we have here are things called asymptotes. And you did have those in algebra when you talked about hyperbolas in algebra. It's sort of a line that goes right by the branch of the hyperbola but never really touches it. And what you're eventually going to do is identify the asymptote by writing the equation of the line. Okay, so these are the components you're going to be working with from this equation and from this equation, which is really the same thing. They're both just standard forms of a hyperbola. Here's what you should notice, though. It's different from the ellipse because it has a minus instead of a plus between. The ellipse was also set equal to 1, but ellipse had a plus here. The hyperbola has a minus. And in the hyperbola standard form, the x squared and the y squared might change. They move, possibly, depending on which way the branches are going. The a squared and b squared always stay in the same spot on the bottom. In the ellipse, the a squared and b squared were the things that were moving around. Okay? Let's just practice a little bit. I think you'll see. I thought it might be a good idea if you kind of highlighted some of these letters. You might be able to see it better so you know where things are. So that's the A's, the vertex is the A's. There's no co-vertices in this picture. Okay. Again, vertex, vertex, focus, focus. Asymptote, you're going to have to work with the asymptote. Okay. All right, again, I wrote the equation, standard form of the equations here. Notice that the x is first, which means the hyperbola branches are going to be on the x-axis. The transverse axis is simply the segment that connects the vertices. So it's this piece right here is the transverse axis if x is first. That's going to be horizontal when x is first. Now I kind of told you you're going to have to identify the asymptotes. Well, since they are a line, to identify them we're going to write the equations of the lines. So this is a little trick here to help you later on when we have to identify the asymptotes. If x is first, the equation of the line is just going to be the b over the a, which is really simply just rise over run. And you'll see that in a minute. And the vertices, when x is first, the vertices are going to be on the x-axis, and again it's going to be plus or minus a, 0. Remember, these are on the x-axis when the a is first. Okay? And the same thing here. When the y is first in the equation, that just means that your branches are going to be on the y-axis, and it's going to be a vertical transverse axis, which is simply, again, the piece here between the vertexes, or the vertices. The asymptotes, which again we will identify as an equation of a line, because that's what they are, they're lines, they would be plus or minus a over b, that's the rise over the run, x. Y equals the slope times x. And then the vertices are going to be on the y-axis, so it's going to be 0 plus or minus a. Remember, if it's in this position, it's on the y-axis. Now, there's also an equation. There's also an equation to help you find the foci. And for a hyperbola, it's c squared equals a squared plus b squared. Notice that this is different than the ellipse. The ellipse was a minus. And here's how I remember it. Okay? Standard form of an equation of ellipse has a plus in between and a minus for the foci equation. Standard form of a hyperbola has a minus in between and a plus in it for the foci equation. Okay, so let's practice some of this. This is just all sort of setting it up here. Turn over. You notice how it's only 2 pages this time. Okay, so here's what you have to do. You have to graph the equation, identify the vertices, the foci, and the asymptotes. Okay, this is A, this is C, and remember this is going to be an equation of a line. Y equals plus or minus whatever the slope is times x. Ready? So, notice, first of all, this is not in standard form. It has to be set equal to 1. So you've got to divide everything by 9 to just get it into standard form. So this is going to remain the same, x squared over 9. This is a minus, so it's definitely going to be a hyperbola. 9 divided by 9 is going to be 1 on the top and the bottom, so it's just going to be y squared divided by 1 equals 1. Okay, now it's in standard form. All right, so notice that the x is first. Okay, let's think about that. If the x is first in a hyperbola, that means that the branches are going to be on the x-axis. And I know that in the denominator is a squared, so that tells me that my a is going to be plus or minus 3. And this is always going to be b squared, so my b is going to be plus or minus 1, because the square root of 1 is 1. Now you kind of want to jump in and just sketch this right away, but I think it's more important to find out what the asymptotes are first and sketch that. So kind of what I'm going to do is I am going to mark my A's, my vertices, and they are on the x-axis. 1, 2, 3 here, 1, 2, 3 here. Okay, those are my vertices. And then I'm going to mark my B's on the y-axis. It's up 1 and down 1. And now remember, the branches are going to go like this. Now the reason I don't just jump right in and sketch these is sometimes they're going to be tighter than others. And so what you want to do first is sketch the asymptotes. And so here's how you kind of do this. It's easy to do it this way. What you do is you just kind of draw a little faint rectangle that goes around these points that you've plotted already. And then you can take a ruler and go through the origin and through the two corners of your rectangle and make another dashed line. And that's going to be your asymptote there. And this way as well, through the origin and through the corners of your rectangles. Oh, now it's beginning to look sort of like the front. Those are my asymptotes. And now I can go back to my vertices and sketch my hyperbola inside those asymptotes. Isn't that a fun word? Now I have a nice sketch of my hyperbola. Okay, so I've done the graphing. Now I need to identify the vertices. Remember that this vertex is -3, 0, and this vertex is +3, 0. So I can write it up here as ±3, 0. Okay? The asymptote, now that means we have to come up with the equation of this line. Now, like I said, you could use this equation right here when we have a horizontal hyperbola, and you could just say, okay, it's b over a. True, b over a is 1 over 3. But just keep in mind that you're writing this equation of this line, and you could also just look at it as a rise of 1 and a run of 3 in this direction. And here it's a rise of 1 and a run of -3 in this direction. So what I really have is I have two equations with the slope of either +1/3 or -1/3 x. Okay, which is really ultimately the same as looking at this b over a. So that's not so bad. All right, now the foci. Remember, to find the foci, you need c. So we need to do this. C squared equals a squared plus b squared. It's the opposite of what's in the standard form here. C squared. My a squared is 9. My b squared is 1. C squared equals 10. Take the square root of both sides. I'm going to jump down here. Plus or minus the square root of 10. And I can just leave it like that. Now remember, the foci are going to be ending up right here on the x-axis as well. And I should have kind of not written those numbers there. Here's my foci. It's about 3.16. Okay? So you would write that as plus or minus square root of 10, 0. Or you could write plus or minus 3.16. It's just not quite as accurate. So there you go. Not so bad. All right, let's do another one. So here we have to get this in standard form. So you go ahead and try that. Okay, this is what you should have gotten for standard form when you divide everything by 36. Notice that the y is in front here. So it's going to be, your branches are going to be on the y-axis, the branches of your hyperbola. Okay, so first of all, let's just consider the vertices. So this is going to be your a plus or minus 3, the square root of that, because that's a squared. And this is going to be plus or minus 2 for your b. So let's plot those real quick. Remember, it's going to be on the y-axis, because the y, so plot 3 and -3. 0, -3, 0, +3. And then let's plot our b here as well. It's plus or minus 2. There's 2, 0, and -2, 0. Now remember, it really works well if you kind of draw yourself this little rectangle between these points. And that helps to do the asymptotes. So go ahead and do the asymptotes. Remember, you draw them through the origin and through the corner of that rectangle that you drew. Okay? Now you can sketch the branches of your hyperbola. Don't jump down here and do it in the middle. Remember, the vertex is where it sort of starts. So I'm going to kind of draw it like this. Sort of a wider parabola. Excuse me, it's not a parabola, it's a hyperbola. Saying the wrong word there. There you go. There's my hyperbola. All right, so I've already identified my vertices. They're on the y-axis, so I can say 0 plus or minus 3. I still have to do my foci, but I could do my asymptotes right now. Remember, it's going to be a y equals, it's an equation of these lines. So you can consider it as b over a, or rise over run. Actually, it's a rise of 3 and a run of 2. Rise of 3, run of 2. That gives me the slope. Okay, so since it goes through 0, 0, I don't need the y-intercept. So it's a rise of 3 over 2. So it's going to be positive 3 over 2 and negative 3 over 2, because a rise of 3 and then left 2. X. There's my asymptotes. Equations of both of those lines. Now remember, the foci is just c squared, a squared plus b squared. C squared equals 9 plus 4. So c is going to be plus or minus the square root of 13, which is approximately 3.6. So I could plot that in. That's not going to be very much further here. These are my foci right here on the y-axis. So it's going to be 0 plus or minus the square root of 13. Okay, so that's graphing. So now we got to do a little bit more practice here. Write an equation of the hyperbola that has a given vertex and foci with the center at 0, 0. Okay, so they're giving me the vertex. Notice that they're giving me the x-coordinate, which means the vertices are on the x-axis. It means it's going to be on the x-axis. Just make a note to yourself, on the x-axis. Which means that x squared is going to come first in my equation. Oop, it's a minus. Equals 1. This is a minus. Okay? So what they're giving me here is they're giving me my A, and they're giving me my foci, which is C. What I need is B. I need B to write the equation. So when I have A and C and I need B, I've got to jump right in and use the foci equation. Okay? C squared is going to be 64. A squared is 25 plus B squared. If I subtract 25 from both sides, I get B squared equal 39. B squared equals 39. And then if I need to, I could take the square root of that, but I really don't need to because I'm just going to plug it into this equation. All right? So I'm going to write the equation here. X squared over A squared, which is 25, minus Y squared over B squared, which is 39, equals 1. And you did it. Okay, yes, this is the same kind of problem, similar, except notice that the vertex or the vertices are on the y-axis, which means the y is going to come first in the general form of the equation. Okay? Again, they're giving me A and they're giving me C. I need B, so I'm going to plug it right into this equation and solve for B. C squared would be 100. A squared would be 36 plus B squared. If I subtract 36 from both sides, B squared is going to be 64. This is what I need to plug into my equation. So I can just jump right in and write that. Y squared over A squared, which is 36, minus X squared over 64, which equals 1. So let's just take a look at that again. If you're given the vertex and you see it's an x-coordinate, that means it's on the x-axis, and you would write it with x squared first in the equation. If you see the vertex and it's on the y-axis, that means you write the equation with the y squared first. Okay? We got one more fun little problem to do here. Okay, a military plane is flying along a hyperbolic path with the focus 0, 2 times the square root of 3. That's my C. And we'll go through the point 0, 2. Okay, so if you look at this picture, you can see this is the focus and this is the vertex. Now remember, vertex is A, focus is C. All right? The center of the town below the flight path is located at X. Write an equation for the path of the plane and how high is the plane when it is directly above the center of the town. So this is 1 and this is 2. Okay, so we can see that the branch of the hyperbola opens up. So I'm going to have this general form, y squared first. And then I got to plug in what I know. So they gave me C and they gave me A. Again, in order to write this equation, I need B. So I have to do C squared equals A squared plus B squared. 2 times the square root of 3 squared equals 2 squared plus B squared. If I make this pretty, it's going to be 12 equals 4 plus B squared. And B squared equals 8. Now this is what I need in order to write my equation. So I'm going to go over here. I'm going to write the equation of this hyperbola. A squared is 4 minus x squared over b squared, which is 8, equals 1. All right. So there I have the general form of the equation. The next thing I need to know is I need to know how high the plane is above the town. Okay, the center of the town, which basically is saying I need to know the the y coordinate of this point on this function here. They're telling me that the x coordinate at that spot would be 3. If I plug it in to my function, then I can find out what the y coordinate is, which would be the height of the plane over the center of the town. So I'm going to plug in 3 for x. Okay, and then I'm going to solve for y. So I kind of got to make this a little bit prettier. 9 over 8 equals 1. And it just seems like it would be a lot easier to finish this problem if I make this into a decimal. So let's just do that. I'm going to go up here. Y squared over 4 minus 1.125 equals 1. Y squared over 4, and then I add 1.125 to both sides. Multiply both sides by 4. I get y squared equals 8.5. And then I got to take the square root of both sides. And y, of course, is only going to be the positive version of the number, since we're talking about a distance here. So that's telling me that the plane, if it's flying this path, is exactly 2.9 miles above the center of the town.